For the second video on Splay tree rotations, I'm going to talk about two different ways to implement a Splay tree. You can implement it top down or bottom up. Top down is going to say you only stay at the root and only operate on the root. And Splay the node that you want to operate on to do. Bottom up is find the node and then Splay up. So the top-down implementation can be done just with a while loop. Keep doing the zig and zigzag rotations to get the node you're looking for up the root until you find it, or until you find that it's not a tree, whereas bottom-up has to be done recursively. Where we talk about the bottom-up implementation for this class, which has to be done recursively. So we're going to talk about how you know which rotation needs to be done and when. You're going to traverse down. I'm going to assume that you know how to find in a binary search tree. So you just, if it's less than step left, if it's greater than step right, and you're able to traverse down to the node you're looking for. The last node you touch, that is going to be the node that needs to be splayed. So for an example tree, 1, 4, 7. If we say find 7, it's greater than 1, greater than 4, and we found it at 7. So we're going to mark this node to be splayed. And as we return it recursively, we're going to look at a few things. After I found it and marked it as this node needs splayed, I step up one level and I say, is this the root? This is not the root. So I know I'm not going to do a zig with my immediate child. Okay? And this is the immediate child. So I'm not going to do any rotation here. Okay? So I step up one more level and I say, is this the root? So I could possibly have to do a zig with a single rotation with just my left or right child. If that root, check both of my children. If I need to rotate zig one of my children up, go ahead and do so. Okay, so this is the zig. If I don't need to rotate one of my children, then I know, so for this case, find 7, I look at this child because 7 is greater than 1. If I don't need to rotate, if 4 is not the one to be splayed, then I step down one more level to look at the grandchild. Okay? So if I need to check the children, if I need to do a zig, go ahead and do so. Check the grandchildren. So it could be the case that this needs to be splayed or this node needs to be splayed. So based on which child, I know I'll either have to do a zigzag or a zigzag. So here I can possibly do a zig, zig or a zigzag. Okay. So that is if I'm at the root. And this is the single rotation case, if I have to rotate one children. Else, if I'm not at the root, if I'm at an internal node, so let's say there's more tree here on an internal node, I only check my grandchildren. If one of my children is the node to be splayed, I don't have to do anything. If one of my grandchildren is the node to be splayed, then I do the correct rotation. So here's where I either do a zig or zigzag. And actually, to clear up a little bit of confusion, I apologize, but zig will be the case. A zig is needed to correct this. A zig rotation is needed to correct this, and a zigzag rotation is needed to correct this. So I apologize for using incorrect terminology. So this would actually be a zigzag or zigzag in same case here. The only thing to note is if you're actually implementing this inside code, be careful when checking grandchildren that one of them are not null. Because it could be the case that I'm at 4 and I go check grandchild and it's null.